Alright, so this is a problem that appears on your homework. That's a little tricky. So the setup is that we're hitting a golf ball. We're hitting a golf ball with velocity or speed v. I know that velocity is not the same as speed, just go with me. It has an angle of theta and it's traveling for t time, so for t seconds. So we're given the horizontal component as x equals v cosine theta of t, or cosine, this is times t, and our vertical component is y equals v sine of theta times t. That t is not on the inside, it's on the outside, minus 16t. And it's we're given the velocity that we hit the ball, and what they want to know is they want to know what's the horizontal difference traveled if the ball is hit at 30 degrees or if it's hit at 50 degrees. So the first thing we're going to do is that we're going to plug this into our calculator. So it's going to be that x1 equals 132 times cosine of 30 degrees times t. y1 equals 132 sine of 30 degrees t minus 16t squared. Okay, so that's going to be one of them. And then x2 is going to be the same thing, we're just changing the angle. So now it's 50 degrees. And y2, same thing, we're just changing the angle. 50 degrees t minus 16t squared. Okay, so let's graph that on our calculator. Alright, so remember to make sure that you're in parametric mode. So you go to your graph, change it to parametric. Alright, so our x1 is going to be 132 cosine 30 degrees times t. Our y2 is 132 times sine of 30t minus 16t squared. Okay, so let's do this one first. So if we graph this, let's go ahead and set our window. Let's make our t go between 0 and, let's make this one 10. So between 0 and 10, we'll have it step at 1. And let's make our x minimum value -1. Let's make our maximum value 200. Well, let's go by 1. Let's make our x min -1. How high can a ball go? Let's try 20. Let's try 20 feet in the air. And let's graph that. Okay, make sure that your calculator is in degree mode. Okay, and our graph doesn't really fit. So let's try something else. Let's try this. Okay, that didn't really work either. Let's go to our window. Let's go between 0. Let's go between 0 and 200. Let's try that. Yep, now see, our graph isn't a smooth line like it should be. Okay, let's try 400 for that. So instead of having our x step equal 1, let's have it equal 0.1. Let's see how that looks. Oh, that is much better. Okay, so a lot of this sometimes can be a lot of guess and check. Alright, let's make that 600. Beautiful. Okay, so then this graph looks like this. Okay, so if you imagine hitting a golf ball, it's traveling through the air and going down. Okay, so it wants to know what's our horizontal distance traveled. So it wants to know what our x point is right here. Alright, so on the calculator you can go to your trace button and you can just scroll over and try to get your y value, that's this here, as close to 0 as you can. right? So we go between 1.6 and -5, and our x value is between 468 and 480. Okay, so that's not a very good estimate. Okay, I'm going to round that. I'm going to say that that's about 472. Alright, now let's check it out for this one. Okay, so just go ahead, I'm going to graph this in my x2. So that's 50. Same thing except for it's 50 degrees. Right, and when I graph this one, it goes much higher. Okay, so this one looks like it's something like this. Looks like it's going way up higher, and it's coming down a little ahead of the other one. Not by much. Right, so let me go ahead and reset my window really quick. Make that one -5. Right, so here's my first one. Let's take a look at the second one. Yep, it looks like it's a little bit further, so we know that this one goes further. Now, we'll use our trace button again. Whoops. I don't want it on that one, I want it on the second one. So to change between the lines, you can just push the button. And notice that the other one's in the air a lot longer. My t equals 5, my other t was about 4. Okay. So this one stops, it looks like it's about 530. Yeah, we'll say about 535 feet. Okay. So then what is the difference of what's the difference of the distance traveled by each ball? So this one went 535 feet, minus this one went 472. Okay. So you just subtract those from each other, and we get the distance is about 63 feet. Alright, now we can also do that algebraically. I think it's easier. You could see that I was having to fuss my window a lot. Also, my trace was off. It would bounce between 534 and then down to 550 something. So let's look at how to do this algebraically. Okay. So I did some of my scratch work. So it wants to know the horizontal distance traveled. So notice that the horizontal distance traveled is going to be when this touches the x-axis, which is going to be when my y point equals 0. Okay? So we're going to see when y equals 0. So we're going to set this equal to 0, and then equals 132 sine of 30 degrees times t minus 16t squared. Okay, now since I have a t here and a t here, I can factor those out. You get that 0 equals t times 132 sine of 30 minus 16t. Okay, then if I divide both sides by t, I get that 0 equals 132 sine of 30 minus 16t. Alright, now I'm going to go ahead and subtract this from both sides. Okay, so it's going to be minus 132 sine of 30 minus 132 sine of 30. Alright, if I plug this in my calculator, I get that negative 132 times sine of 30 equals negative 66, which equals negative 16t. Right, then I divide both sides by negative 16, so I can get t by itself. And I get, negative 16. And I get that t equals 4.125. Okay. So now that I have this, I can plug it in to find my horizontal component. Okay, so now I have that x equals 132 cosine of 30 times, and I know my t value. The t value is 4.125. If I enter this in my calculator, cosine of 30 times 4.125, I get that my x equals 471.55 feet. Right, which actually is pretty close to what my calculator traced it out to be. Okay. Right, so now that we have this one, let's go ahead and solve the other one. So remember, same thing here. I want to find what my t value is when my y component is 0. Okay? So my y component equals 0 when my curve crosses the x-axis. So we'll set that equals 0, equals 132 sine of 50 times t minus 16t squared. I can factor out that t again. It's 0 equals 132 sine of 50 minus 16 t. Factored out that t. Now if I divide both sides by t, I get 0 equals 132 sine of 50 minus 16t. Subtract this from both sides. Okay, if I plug 132 sine of 50 in my calculator, so 132 sine of 50, I get negative 101.12 equals negative 16t. Divide both sides by negative 16. And I get that t equals about 6.32. Now that I have this value, I can plug it back into here. Oops, I forgot a t on here. Okay, so that means that my x is going to equal 132 cosine of 50 times 6.32, that's my t value. Alright, and then I get that my x value is 536.24 feet. Okay, which, if I look at my graph again, is pretty close. Right, we were off by 1.24 feet when we did it graphically. Alright, which was a pretty good estimate. So that is going to be a problem in your homework. You're going to have to know how to do both graphically and probably algebraically.